Hello YouTube, I'm Philipp Meyer. I'm collecting vintage computers and technology in general. And in this video I will show you how I repair my old dectalk dtc01 speech synthesizer. Yeah, this is it. This is the dectalk speech synthesizer from digital equipment. To be precise, it's the dtc01, so that's presumably the first version they produced. I got it from an online auction, and of course they didn't lie about the fact that it's defective. So they sold it as defective, and it really is. It does turn on, but it just does nothing. It has here at the back, it has a few status LEDs. Yeah, and these LEDs are flashing in a weird way. I couldn't really figure out using the manuals, so there must be something wrong. It's presumably some error coding. Yeah, and then we have two serial connectors. So the one with the little screen logo, that's not for a screen to connect. It's for connecting a terminal, and this is something like an operator console. So this is meant for configuring the dectalk, sending text to it to have it speak it, but that's not really for machine to machine. So it's really it's more man to machine, and yeah, the machine to machine interface is here. This is the COM interface. This is supposed to be connected to a server or whatever it means in the age where this is coming from. It would be presumably a VAX or a PDP-11, and there the machine would send commands and words to be spoken. So that's basically for the machine, and this is the human interface. And then we have a lot more. We have a phone interface. And this is really cool. So you can hooks up to a phone line and basically make something like a voice terminal. I don't think it can detect DTMF tones, so you would need a separate hardware for that. But you can directly speak through the phone line and basically make a programmed voice output. And here you have an aux and a headphone jack, so you can connect it to some amplifier or some computer the analog way, or just have headphones so you won't disturb anyone while designing menus or whatever. Yeah, here we have a power LED that lights green and just indicates that power is present, and we have a volume control, and yeah, very important for me since I imported that from the US. Underneath this little protective sticker we find the little switch to switch between 230 volts and 110 volts. So if you import a dectalk, have a look at this switch before powering it on. Yeah, other than that, there's really not much to it. It's just a yellowish plastic case. I already did some work to it. I dumped the firmware out of the rather large firmware ROM. It's a 256 kilobyte firmware in there, so that's really huge, and it spreads over 16 EEPROMs, so that's quite a bit. We also had this problem with the filter capacitors in the power supply again. Unfortunately, I didn't look first and got a smelly living room again. Yeah, my recommendation is to look out for these yellowish caps first and exchange them, so they will explode. So since the device is now safe to power on, let's have a look at it, and let's try to find out why it doesn't work. So I've set up my dectalk here in a way where I have a good access to any component here. I must say, actually, these dectalk thingies are very serviceable. The PCB can be pulled out without using any tools, by pulling these little plastic knobs here, and it's all made with plugs and so on. Yeah. here that's obvious. We have the power supply here, and this is a built-in speaker, so this is a very nice and practical thing that it has a built-in speaker, so you do not have to connect anything in order to use it. So no external speaker or amplifiers are required. This thing seems to be run entirely from an Motorola 68K processor. And given the fact that this thing is from 1983, you can see it by the date code from the ROMs. This had the power of a quite decent desktop computer in these days. But in the end, it's in 68K processor board. Here at the bottom, presumably this is a DSP. I didn't look it up, but it seems to have its own ROMs. Yeah, and then we have RAM. It's okay if some of the modules are missing. I think depending on the firmware, the different amounts of RAM is required. I think having 6 RAM modules here, MRAM chips, is standard here. But yeah, I presume that DEC wanted to have it upgradable in case they support different languages or whatever. Yeah, and then we have the really huge EEPROM bank here. I never seen anything like that. I mean, normal is about 2 EEPROMs or something, but this is just huge. I mean, it's 16, 27, 128, and I presume that you have always 2 of them, because this is a 16-bit processor and these ROMs have 8-bit data. Presumably you need always 2, so this is basically 1 bank, so this would then have 8 banks in the end, and same might be true here. I didn't look too much into the schematic because I already have an assumption what might be wrong. So let me show you what happens when I turn it on. See nothing, then the amplifier of the speaker is coming up, and then you see these flashing LEDs here, and nothing further is happening. So this LED pattern doesn't match anything I found on the internet. These LEDs are intended to be some status LEDs. Basically, they are used to monitor the activity on these ports here. But I think it's not really normal that these LEDs are flashing the way they do. So engineering drawings are your friend. And by the way, here you can see how the 2 banks are basically made up into a single 16-bit word length bank. Here you see 0 to 7, and here you see 8 to 15, so that's how you get your 16-bit word length. So yeah, it looks like I was right, but I'm looking for something different here. Here, that's what I wanted to show you. I mean, it's obvious, but this is a register that holds the value that's basically displayed on the small LED display here. I see it because we have a CLR and a clock here that is connected to this and with inverted inputs. Here see lower right enable something, chip select. I mean, that is a register and it has to be maintained somehow, so it probably sits on the bus somewhere at some address and it's written actively, and that's how the LEDs are flashing. So what tells us this is just that the CPU is up and running, so it does things. I mean, it doesn't much, but it lets the LEDs go on and off. and that's a proof that that most likely we have a functional computer. So the computer in that system works. That's what we know now, but we don't know anything else. So I already checked the COM ports at the outside. They are completely dead. And that leads me to the assumption that it might be that this LED flashing is the result status code from a basic power on check. And yeah, I think what we can do now is we can try to play a bit with the board to see how it behaves if we do stuff to it. So let's go back to the board and try stuff out. Okay, well, repairing things is not only about technical knowledge. I mean, it's also very much about, basically feel it in the stomach what might be wrong. So what I now want to try is what happens if I take out any of these ROMs. So how would the system behave? So let's see what happens. So it's not much different other than the LED flashing pattern had changed a bit. So put it back in. The old behavior came back. So that must be a fault that sits somewhere in a very early boot up stage. It could either mean that one of the peripherals is dead, or it might even mean that the RAM check is failing, or it might be that the ROM check is failing. It might also mean that the DSP has some failures. This one we could theoretically check. We could take out the ROMs and see if the pattern somehow changes. So the DSP circuit should now be artificially dead, so let's see if this thing notices it or doesn't notice it. Yeah, still the same as always. So that could either mean that the check fails very early, so it has no chance to checking it, or it just doesn't matter. So we have a lot of these spring-loaded sockets here. These things are just awful. I mean, they tend to go bad after some time, or at least if they corrode, there might be an improper connection. So what I usually like to do is I take the parts which are socketed, I take them out and put them back in immediately to ensure that there is a proper contact. Because when the metal of the springs and the pins are rubbing against each other, usually you get a proper contact. Yeah, I did that a couple of times. I mean, during the reading process I had this entire section out. I already tried to wiggle this one a bit. So I think the connections are pretty good. So let's think for a minute, what else could it be? So it's definitely code. It's not code that sits in here, so that can be ruled out without even looking at the schematic. So this is for itself. So the code must sit somewhere here. So, and yeah, what can you do? You could disassemble the ROM contents and try to spot a loop and try to look up what it really does there. So what's the check is that fails. But there's another thing we can do, and it's fairly easy to do it for us, because on the internet I managed to find a set of ROMs, because this board is also available in the MAME emulator. or presumably available. I didn't try it, so yeah, a lot of things in MAMEs are broken. So yeah, I mean, maybe you have the time to try it. But I have some ROMs, and what we could do is we could compare the content, the ROMs from the internet, to what I've read, what I've dumped from here, to see if the ROM content here is correct, because the flashing also could mean that that we have somehow an invalid ROM content. I mean, I don't even know if these ROMs are the proper set. I mean, that seems to, it looks a bit like it was firmware upgraded several times. Yeah, there's these round sticker ROMs, and there's some with these square labels, and there's even one that has some more elaborated label. It says digital dectalk. So there are many possibilities, and I think one that's really simple to check is if the ROM content looks still good. I mean, it's from 1983, that's about 34 years from now, so it's likely that at least one of these EEPROMs lost its content, at least partially. So let's run a check on that. Yeah, when I did the ROM dump, I enumerated my ROMs with a pencil, like 1, 2, 3, 4, and so on. DEC had a more, a little different way to enumerate their ROM saves. Basically, each socket has an E number, and here it starts as E1, E2, and so on. And when you download the ROMs from the internet, you get a package where you have, I think, 2 ROM versions and 3 DSP ROM versions in one directory, and you get a bit of a mess. But you still get a recognizable, very recognizable SC E number at the end. So basically, we have to find files that have where the E number is matching up here. So I say that just you are not confused while doing the comparison. And to make it easier, I have already put my ROMs that have just a number and a .bin into the same directory. That's all. So yeah, let's do some diffing on the ROM images, I would say. So if you want to diff the first ROM, you have to look for an E22 file here, and you see I already found 2. So I will just compare both of them to the one.bin file I have, and we'll see what the outcome is. So here I done it. I mean, it's just simple. I just diffed 2 files, and for one I see they differ, but for the second one I see they match up, so there's no output. And that basically means that the one.bin I've read from the ROMs is a good ROM file. So yeah, let's do the same for number 2, and that will be then the E21. Yeah, so here we notice something odd. We can clearly see I diffed the 2 files that match for my second ROM, and they both differ, so that's certainly not good. So we will have a look with vbindiff now to see what's up there. Yeah, that kind of looks interesting. I compared the 23120E5 now, and yeah, my experience says that this looks kind of odd, because normally if you have a firmware upgrade, for example, if you recompile and do all the stuff, you have huge shifts in the ROM content, so you won't end up with some tiny bits changed here and there. But let's have a look to the other ROM and see how the image looks there, and then we will compare. Yeah, and you see what I mean. I mean, that's the usual case if you change bits and recompile. So that's what I expect if it's a different firmware version. So yeah, let's analyze it further. So here we are with the odd looking ROM again. So what I basically did is I looked at these two windows here. Here we have the 2.bin and here we have the ROM from the internet, but it doesn't really matter to which side you look at. I just wrote 5 of these bytes here and compared them directly. So what you can immediately see if you convert them to binary, you immediately notice that the bit number 6 here is just seems to be zeroed out. So here in the upper one is the ROM from the internet, so it should be all ones, but it's 1 0 1 1. And here again 6 bit is missing. It's missing again. Stop to 0. Here's 0 and here's all zeros because that was the only bit. The other nibble is okay, and you can spot also. You can spot it somewhere else in the ROM as well. So here we have a 6E. Here it got a 2E. Here's a C0 2 times, and here it's an 8-0. So one of the nibbles is always dead. So this pretty much looks like a bad ROM. So the ROM somehow got bad. This is a very classic failure. One bit just somehow is knocked out. So what we now just do is as we have the content, the original content from the ROM, so we know what's right, so we can correct it easily. This would look way different if we wouldn't have the ROMs from the internet. So let that be a warning to you. If you have vintage devices, do backups of your EEPROMs. You can lose the EEPROM content and then you have nothing in the end. It simply doesn't work anymore. And if you are not having a very popular machine like a Commodore 64 or some popular Robotron stuff like the KC, you won't get your machine back. There's just no way. I mean, of course, you just don't know really what's wrong. I mean, in this case, we wouldn't even know where the fault were. We wouldn't even know that it's faulty. So if you don't have nothing to compare with, you're basically lost. So but now let's do some work and create a new EEPROM. When I'm repairing things and doing experiments, I usually avoid overwriting the existing EEPROMs because I want to be able to reconstruct everything. So we won't erase that one and try to rewrite it. So we will instead use this one here I found in my basement. Before we can use that, I mean, the younger folks of you might not know, but this little window here is there for a reason. So these memories are erased by exposing them to UV light. This is a very, very early version of what you currently have in your mobile phones and everywhere else. These could only be written with a high voltage. This was labeled here. In this case, it's 12.5 volts. So that's the voltage you needed to supply if you wanted to write content to it. And after that, you couldn't write them at all. They were just good as any other ROMs. So it gives this one so we will expose it now to UV light. This kind of light is a bit dangerous. I wouldn't remove the case and turn it on while it's running. So this needs to be exposed a few minutes. I usually don't count it too precise because I will run a blank check anyway. So I will check with the EEPROM program if that erasing really worked. Okay, let's see now. I can smell it. Great. So now let's try to write some data to it. So here we go, SGS Thompson. It's important to pick the right one because we want to get the programming voltage right. Yeah, let's start to program it. That takes a bit longer than the reading process. That is just because the address in the data has to be present for a certain amount of time in order to get programmed properly into the EEPROM. Okay, fine. So back to the dectalk now, and yeah, let's see if we reached something here. Yeah. Orientation always check twice. Okay, does it sit properly? Yes, it does. So let's go.
dectalk version 2.0 is running, and we are fault using factory settings.
Yeah, doesn't it sound great? I think that's success. Thumbs up. So well, I've set up with the dectalk now on my laptop, and I have a terminal window here, and I'm now connected to the human interface console, and now I can just type something and have it spoken like this. Hello, I am dectalk, like this, for example.
Hello, I am dectalk.
So it just speaks it. So yeah, that's basically how it works. There's more. dectalk has a variety of configuration parameters and yeah, basically options that alter the voice output. And one of their major features is that you can change the voice type of the dectalk, and they have about 8 voices here. I think it's 8 different persons, and they gave them funny names like Russ, Rita, Frank, and you, Cherry. And yeah, to select them you need a control sequence. There are different of these control sequences. One sec. You can, by the way, change the rate, but yeah, we won't do that right now. I just want to demo how to select the voice. So here we have a table, and yeah, Perfect Paul is the voice that is enabled by default, and yeah, let's suppose now to change the voice to Huge Harry. We can do it at any point in time. We can just issue the control sequence and it will change immediately. So that's a double point and then NH. So we go back to the terminal and try that now. Important to know, for the control sequence you need these square brackets. You have to write them in square brackets, and then NH. So now it should have selected Huge Harry now, and let's see how Huge Harry is sounding. Is Huge Harry.
This is Huge Harry.
So yeah, this sounds a lot different. So yeah, you can change. You can select from a menu of 8 different voices, and you also have direct phonemic input. So, but that would lead way too far. The basic thing is just every word needs to be disassembled into phonemes, and there's a library inside that does it. And in case there's a word that isn't in that library, you can basically program it on your own using the direct phonemic input. So, well, I hope you found this video informative, and if you have the feeling that you heard this voice before, you might be right, the same voice Stephen Hawking is using to talk. So, well, see you, bye bye.